Okay, so here we're going to look at the chain rule in a bit more of an application sense. And we're going to use a chain rule to differentiate these sort of functions and then find the equations of their tangents. So it's been the same thing that we've done before, where we're deriving by finding tangents or coordinates or tangents. But now we're just using them on functions that we need to use the chain rule with. So to start us off with the first one, I've just started it. So it's the square root of x squared minus 2x plus 5. And as we know, I've just rewritten that as as a as an indices because that makes it easier for us to differentiate this in the future. So again, if you remember our rule from earlier on, where we looked at quicker rules for the chain rule, basically said that if you want to derive a function that has some sort of power, what we do is we bring the power to the front, and then we leave the function as it is, and the power of that function reduces by 1, and then we just times that by the derivative of the inside function. Okay, so whatever the inside function is, we derive that and we multiply that at the end. So we're going to be following the same sort of rule to answer this question here. Okay, so we've got y is equal to x squared minus 2x plus 5 to the power of half. So first thing I'm going to do is I'm going to bring the power down. So the power is a half. So I'm going to bring that down a half. Then we're going to leave the function as it is. X squared minus 2x plus 5. And then we're going to reduce the power by 1. So that becomes minus half. And we have to multiply that by the derivative of this actual function that's inside. So the derivative of this, derivative of x squared is just 2x. Derivative of 2x is just 2, and plus 5 is a constant, so that just becomes 0. So the derivative of this is, now we don't want negative indices in our equation, in our answer, so we're going to rewrite this again into third form. So what we'll do is we'll leave 2x minus 2 in the numerator, and we'll bring this into the denominators. And we can put it back into the square root format. So that becomes 2, and then x squared minus 2x plus 5 to the power of half. And then we can rewrite that as 2x minus 2 over 2, and then square root of x squared minus 2x plus 5. And there's your derivative there in a nice and neat manner without any sort of negative indices or anything like that. We're not done yet though. Now we need to find the equation of the tangent at point P is true 0. So what we do is we'll first find the gradient at this point. So as we know, this is the gradient dy over dx. So at point 2, so what we'll do is let's continue down here. So at x is equal to 2, our dy over dx is going to equal to 2 times 2 minus 2 over 2 square root 2 squared minus 2 times 2 plus 5. So we're going to leave this in exact format because if we just put this in a calculator, you're most likely just going to get a random decimal answer. But if we just leave that in simple format, this is just going to become it's just going to equal 1 over root 5, simplified. So let's just get our pen. So you put in your calculator. So if you want to do it in exact form, what you will do is just, you can put this in the calculator. Just put this by itself. Whatever's in the square root, just put that by itself, and then just put the square root around. So if you just put 2 squared minus 4 plus 5, that will just give you 5. So this is 2 root 5, and this is 4 minus 2. So it's 2 over 2 root 5, which just becomes 1 root 5. So that's our gradient, right? Now, using our points for form, we know that to find the equation, we will do y minus y1 is equal to m x minus x1. Okay, now also just put our point down here is also the point that we had was true and 0. So point P is true and 0. So true becomes our x1 and 0 would be our y1. Okay, so subbing in these values, and this would be our hem. So subbing in these values now into this formula, you know that y minus 0 is equal to 1 over root 5 x minus 2. So therefore, y is just equal to, you can rewrite this now into point gradient form. So y is just equal to 1 over root 5x minus 2 over root 5. And there's your equation of the tangent at point 2 and 0. Okay. Same thing for this second question. This one's a bit different. So instead of a square root now, we've got a fraction inside. So we've dealt with fractional indices before. And what we're going to do is when our again inside this function, we're going to remove that fraction and just rewrite it as a negative indices. So x plus x minus x to the power of minus 1 to the power of 4. Okay, that's our y. And now I'm just going to use this formula again that we've explained here and derive this. So dy over dx is equal to, so first thing we're going to do again, bring the power down. So we're going to multiply that by negative 5 at the front. And the power is 4, so that's multiplied together. Then we leave the function as it is. I just reduce the power by 1. And then we multiply this by the actual derivative of this function. So the derivative of x is just 1. And the derivative of x to the power of minus 1 becomes minus x to the power of minus 2. Right? Same thing, we're bringing the power down and then reducing the power by 1. Okay? So simplifying this, we get negative 20. And you have x plus 1 over x to the power of 3 multiplied by 1 minus 1 over x squared. In case that's what our derivative is going to be. Now again, we want to find the equation of the tangent at point P, which is true 0. So at x is equal to 2, we want to sub this in, and then we need a calculator for this one. So at x is equal to 2, dy over dx is equal to negative 20, and then we've got 2 plus 1 over 2 to the power of 3. Then we've got 1 minus 1 over 2 squared. Okay. And putting that in your calculator, you won't have to worry much about decimals or anything like that over here. Just rewrite your answer in fraction form. And if you just put this in your calculator, you're just going to get negative 1875 over 8 in simplified form. Okay, so again, putting down my point. So our point is true and 0. So that's our x1, that's our y1, and this is our n. So using that, we're again going to use this formula, y minus y1 is equal to m x minus x1, and we're going to sub in those values again. So y minus 0 is equal to negative 1875 over 8 multiplied by x minus 2. Okay, so again, it just becomes y is equal to negative 1875 over 8x. And then your y-intercept is just going to be, well, you just multiply this by 2. So that will just become plus 1875 over 4. And that's the equation of the tangent to that equation. Well, that's the equation of the tangent to this curve at the point 2 and 0. Same thing as before, we're just applying chain rule. And yeah, this is just the key form, I guess, that really helps with these sorts of questions.